Hey everyone, welcome back for another deep dive. Today we're going to dig into a topic that I know keeps some of you up at night, and it's one that I've certainly grappled with. We're talking about how to handle databases when you're in the world of microservices.
Database is always a fun one.
Right. So, microservices, they promise all this wonderful independence and flexibility, but then data decides to show up, and sometimes it feels like it throws a wrench in the whole thing.
It can, for sure.
So to help us unpack all of this, we're turning to the wisdom of Chris Richardson over at Microservices.io. He's got a ton of great stuff on this, so we're going to be pulling from his work today as we kind of go through this thought process together.
Sounds like a plan.
So imagine this. You're building this amazing new application. You've got your microservices all neatly separated, each doing their own thing. But then, boom, you realize they need to actually, talk to each other, share some data. And suddenly this whole idea of a shared database starts looking pretty tempting, right? Just one big pot for everything.
It's definitely the first instinct a lot of people have, especially if they're coming from that more kind of monolithic application background.
Yeah, it feels familiar.
Yeah.
But as with most things in software development, it's not quite that simple, is it?
Not quite. There are some pretty important forces at play that we need to consider when we're thinking about data and microservices.
Okay, so lay it on me. What are these forces that we need to keep in mind?
Well, on the one hand, we've got this whole idea of microservices being independent. That's like the holy grail, right? You want to be able to develop them separately, scale them independently, all that jazz. But then the other force is this reality that sometimes actions within your application require a more, holistic view of the data. Things get a bit intertwined.
Gotcha. So it's like this balancing act between keeping things separate, but also recognizing that sometimes they need to connect in meaningful ways, data-wise.
Exactly. And to make it more concrete, let's picture a classic example. An online store. We've got an order service handling all the ins and outs of processing purchases, and a customer service managing customer accounts, credit limits, all that good stuff.
Okay, so far so good. Our services are neatly compartmentalized. What could go wrong?
Well, let's say a customer is ready to click that Buy Now button. The order service needs to do its due diligence, right? Make sure the order total doesn't exceed the customer's available credit. But that credit information, that lives over in the customer services domain.
So we've hit a point where our independent services actually need to communicate, and not just in a, hey, how are you kind of way.
Right. And not only do they need to talk, they might need to update information in multiple places as part of one single atomic action. Like, we don't want the order to go through if there's not enough credit, and we certainly don't want the customer to be able to place multiple orders while their credit's being checked. Things could get messy fast.
Yeah, you'd have some unhappy customers on your hands. So this is where this whole shared database idea comes into play. Like they both just use the same database and problem solve.
That's one way to approach it, and it can be tempting, especially because with a shared database, you can often rely on these things called ACID transactions to keep things in check.
ACID transactions. Okay, I think I vaguely remember those from my database class. But remind me, what's the significance of ACID in this scenario?
So ACID stands for atomicity, consistency, isolation, and durability. And essentially, it's a set of properties that ensure that database operations are processed reliably. In our online store example, those ACID properties would guarantee that if a customer tries to place an order, the entire transaction checking credit, creating the order, updating inventory, the whole shebang either completes successfully or it fails completely. There's no in-between, no weird half-updated state.
Got it. So ACID is like our safety net, making sure everything stays in sync even when multiple services are involved.
Exactly. It's a way to maintain data consistency in a multi-service world, even when you're using a shared database.
So it sounds like the shared database pattern, while maybe a bit simplistic, can work in some cases.
It can, but.
Right.
And you knew there was a but coming.
There's always a but in software development.
Right. So while a shared database might seem like the easiest path at first glance, it often comes with some potential drawbacks that can really bite you down the road.
Okay, I'm listening. What kind of drawbacks are we talking about here?
We'll delve into that right after this. Well, the biggest one, and this is something Chris Richardson talks about quite a bit, is the issue of coupling.
Coupling, right.
Yeah.
That doesn't sound like a good thing.
It's not ideal. Basically, when you have a shared database, your services become, coupled to that database and potentially to each other through that database. And this can create all sorts of headaches.
Headaches like, give me the specifics. How does this coupling actually play out in the real world?
Okay, so let's say you need to make a change to the database schema, maybe add a new column or something. With a shared database, That change could potentially impact all the services that use that database. Suddenly, you're not just making a simple change, you're coordinating a potentially risky deployment across multiple services.
Yeah, that sounds like a recipe for disaster. One little change could snowball into this huge, complicated mess.
Exactly. And that's just on the development side. There's also what we call runtime
The
coupling.
runtime coupler. Okay, now you're just using fancy words to scare me.
It's not that scary, I promise. Runtime coupling basically means that the performance of one service can be impacted by the actions of another service, all because they're sharing the same database. So imagine one service is running this really complex query that's putting a lot of load on the database. That could slow things down for all the other services that rely on that database.
Ah, I see. So it's like everyone's fighting for the same limited resources, and if one service gets a bit greedy, everyone else suffers.
Precisely. And that can lead to all sorts of performance issues, slow response times, even downtime. Not a good look for our online store.
Definitely not. And on top of that, what if, down the line, our services start to have very different data needs? Like, what if the order service is perfectly happy with a traditional relational database, but the customer service wants to start using a NoSQL database for some of its data? We'd be kind of stuck, wouldn't we?
You would. Trying to shoehorn everything into a single shared database can really limit your options and your ability to choose the best tools for the job.
Okay, so while a shared database might seem appealing at first, it's not without its pitfalls. But before we completely write it off, let's play devil's advocate for a moment.
Yeah.
There must be some scenarios where this pattern actually makes sense, right? Not every application is going to be this massive, complex beast with wildly different data needs.
Absolutely. I don't want to give the impression that the shared database is always the wrong choice. It can be a perfectly valid approach, especially for smaller applications or teams that are just starting out with microservices.
So if I'm a developer who's just dipping my toes into the microservices world, maybe I've got a new project that's still relatively small scale, the shared database might be a reasonable place to start.
It could be, especially if your team is already comfortable working with, say, relational databases, and you're not anticipating massive growth or wildly divergent data needs in the near future.
So it's all about context, as always.
Yeah.
There's no one-size-fits-all answer in software development.
Exactly, and that's why it's so important to understand the trade-offs involved with different approaches, like the shared database pattern we've been discussing.
Speaking of different approaches, earlier you mentioned something called database per service. I'm intrigued. What's that all about?
Well, imagine this. Instead of having one big database that everyone shares, each microservice gets its own private database. It's like giving each service its own little kingdom to rule over.
Interesting. So in our online store example, the order service would have its own database, the customer service would have its own database, and so on. No more sharing one big apartment complex.
Exactly. And this separation of data can bring a lot of benefits in terms of decoupling and flexibility.
Okay, I'm starting to see the appeal. But if each service has its own isolated database, how do they communicate? Like, how does the order service still check the customer's credit limit if it can't directly access the customer service's data?
That's the million-dollar question. And it's one that leads us into the fascinating world of distributed transactions and inter-service communication.
Oh, I'm already sensing it to be continued.
You got it. We'll dive deep into those topics in a future episode, but for now, I think it's important to let our listeners digest what we've covered so far.
I agree. So before we wrap up our thoughts on the shared database pattern, any final words of wisdom for our listeners?
Just to reiterate, the shared database pattern can be a valid choice, especially when starting out with microservices. But as your application grows and evolves, it's crucial to be mindful of the potential drawbacks, particularly the coupling it introduces.
Coupling, being that interconnectedness between services that can make changes and updates tricky and potentially lead to performance issues down the line.
Exactly. So as you embark on your microservices journey, make sure you have a solid understanding of the trade-offs involved with different database architectures, and don't be afraid to explore alternatives as your needs change.
So to sum up our deep dive on this shared database pattern,
Yeah.
it's kind of like starting with a cozy cottage, right? It works right in the beginning. It's simple. Everyone knows their way around.
Yeah, feels manageable.
Exactly. But then your application starts to grow. You're adding more features, more services, and suddenly that cozy cottage feels a bit cramped. You're bumping into each other. Things get messy.
And you're starting to realize that maybe, just maybe, you need to rethink that open floor plan.
Right. Walls, who knew? So as you venture further into the world of microservices and databases, remember that there's no one right answer. What works for one application might be a disaster for another.
It's all about context.
Exactly. And that's what makes this field so exciting, right? There's always
Oh.
something new to learn, new challenges to tackle.
Absolutely. It keeps things interesting, that's for sure.
So whether you decide to stick with a shared database for now, or you're already brainstorming ways to give each of your services their own little data kingdom, the important thing is that you're making informed decisions.
Couldn't agree more. Informed decisions and maybe a little bit of experimentation along the way.
Always. A little experimentation never hurt anyone. Big thanks to Chris Richardson again for his awesome insights on this topic. Be sure to check out microservices.io for more on this and a whole bunch of other great microservices goodness.
And hey, if you're enjoying this deep dive into the wild world of software architecture, be sure to follow us, Code Impact, on Apple Podcasts, Amazon Music, Spotify. You know the drill. We're out there.
Until next time, happy coding, everyone.